Hi, in today's video, we will see Introduction to Machine Learning. We will find out what is human learning, what are the different types of human learning, and what is machine learning. It was 20 years ago when there was a computer program which was developed by IBM called Deep Blue, which defeated world chess champion Garry Kasparov. Since then, people gave serious attention to the computer emerging field of AI, that is nothing but machine learning. Today, machine learning is a mature technology which finds its application in all the aspects of our life. Basically, you will find an application of machine learning around everywhere. Say for example, there is a recommender system which can recommend toys to a toddler, or it can also recommend scholastic articles such as literatures to the geek. It can also recommend video to a person who is entertained by a specific category. Not only recommendation systems are covered by machine learning, but also machine can also predict some values or class. Say for example, it can predict future market for a incompetent trader to find out the stocks in the future. Or it can help healthcare industry experts to find out the type of tumor. Say for example, tumor is very dangerous to health in an upcoming year, that is malignant, or it can be benign, a simple tumor which will not make any health risk to human person. It can also help weather department to find out the cyclone severity or the temperature that are upcoming for the years. Machine learning can also help us in optimizing energy consumption, which is nothing but a good cause of green earth. Say for example, we want to find out the number of servers which can turn up and off automatically as per the load. Or we have to regularize the energy consumption by the smart home devices. All these can be managed and better plan for the energy consumption can be made for an optimizing energy with the help of machine learning. As of today, there are competent and there are front runners on research of machine learning and AI, and Google is one of them. Google's two ambitious projects, say self-learning cars and Google Brain, are good example of research in machine learning. There are others too. Say for example, Google Lens. Whenever you click a picture of some particular object, it will try to identify the objects in a picture and try to recommend scholastic articles or a shopping website which can give information to the same type of objects. So these are nothing but very good example of machine learning and AI. Field of computer science was actually emerged in the 1950s when Alan Turing proposed a paper called as Computing Machine and Intelligence. So from where 1950s a question was arised, can machine think? Later on there was in 1952 there was a scientist in an IBM called Arthur Simmel who proposed or who started actually working on machine learning program which could actually play checkers game. And later on there were numerous findings were made in a stream of machine learning. And since then journey started of machine learning. And today you will find number of hundreds of machine learning algorithms which are actually formulated by different researchers in the field. To understand how actually learning process of machine resembles, let us understand first what is human learning process. From a cognitive science, learning is a process of gaining information through an observation. But basically, why do we learn? We actually learn to carry out our daily life activities. These activities can be as simple as walking or talking or doing an homework. It can help us to carry out difficult activities or complex activities. For example, diagnosing a patient, or we have to find out an angle of rocket launch so that a rocket will set in its correct arbitrary. So here, no matter whether the activity is simple or difficult, we need to learn it in order to do it correctly. How learning will happen? Learning will take place only we have something called as prior information which is related to that task. Unless and until we don't have prior information, we won't be able to learn doing new things. And to do these things more correctly, more efficiently, or more error free, we must keep on learning to improve the ability to learn these tasks. That's why we say with more learning of a task, we can perform the same task more efficiently. Let us understand how or what are the types of human learning. Basically, human learning happens in three stages or in three types. First one, you can learn to do things in the expert guidance. You can learn to do things from a knowledge which is being gained by an expert, or you can learn the things by yourself. Let us understand these three categories in detail with the help of an example. Learning under expert guidance. Basically, you are getting a direct knowledge or direct information from the experts in a field. Say for example, toddler will try to identify or will figure out what is called as color blue, which is being guided by its guardians or a parent. When they are introduced some shapes like it is circle or it is a rectangle, it is nothing but learning under the expert guidance. Here, humans are actually learning from the field expert. When a toddler or a young kid goes to school, basically the knowledge of alphabets and numbers is gained from their teacher. Now, teacher is an expert in the field who is having prior expertise or prior experience in their field. So they introduce alphabets and numbers to young kids. When person goes to high school as an adult, they are introduced to sentences or complex grammars or complex maths. All these information again is coming from the expert who is having prior information or prior experience in their field. When joining our higher studies, we are actually learning application oriented skills. Say for example, an engineer student, we will learn our application oriented knowledge. Say whether it is civil engineering or computer engineering, we will learn the concept related to our field. Or medical students will learn about biology or zoology or botany in their field. So these are nothing but their career oriented or career specific skills or knowledge they are getting from their expert faculties. Does learning stops there? Of course not. When working as a professional, we go through training. During that training, mentors are the person who are having prior or experienced knowledge in their field. They guide us to do the task more efficiently. So during this particular phase of life, in different stages of life, the guided learning part is unavoidable. We always learn directly from some other human who is having prior experience in their field, which is called as learning under expert guidance. So in all phase of life, guided learning is an element which is unavoidable. Second type of learning is learning guided by knowledge, which is gained from expert. Here, learning doesn't happen directly or we do not gain direct information from our experts. But whatever the knowledge or whatever the information which is imparted by these experts is applied in some different context or in different application. Say for example, there is a young one who knows what is called color blue and what is called color red. Given a set of objects to a kid, he or she will be able to differentiate between or try to group all the objects which are of type color blue or which are of type color red. No one have taught that kid as a to group blue objects and red objects separately. Similarly, a student will be able to identify an odd word from given set of verbs and adjectives. Say for example, in a given set of words, there are 5 verbs and 1 adjective. So that will be separated by or identified by a kid only when they have prior knowledge of what is called as verb and what is called as an adjective, which is a knowledge given by their English subject teacher. So here, no direct learning process will happen. We have some knowledge, we have obtained some knowledge in some past time, and that knowledge is applied to the new context or a new application to do some new type of learning. That is nothing but learning guided by knowledge which is gained from an expert. Third type of learning is learning by self. Obviously, there are some tasks which are left on human to learn by their own. There are some tasks which cannot be taught by others. Say for example, toddler is observing others that they are walking with the help of their leg. So they will try to identify and try to find out that legs are there to walk. They will find out a floor with some of the obstacles through which they are always and always going to get bumped. And later on, by trial and error or by doing or practicing the same task again and again, they will learn how to walk. Similarly, riding a bicycle is another example of learning by self. You will try to find out using an experience what are the things we should do or what are the things we should not do. There is a long list of the tasks which can be learned by ourselves and which is not taught by others. And these are the things we learn from an experience or trial and error basis, or going failure many times and doing the things correctly later on. So this is the third type of human learning called as learning by self. Now let us discuss what is machine learning. The informal definition of machine learning says that an ability of computer program to learn by itself. But this does not give us any technical details. So what is formal definition of machine learning? Machine learning formal definition is given by Professor Tom Mitchell, who defines machine learning as a computer program is said to learn from an experience E with respect to some task T with a performance measure P only if it performs task T which is measured its performance or which improves its performance with an experience E. Now let us understand this particular definition by an example. Say for example, I have a computer program which reads email of a person and try to label that email as spam or not spam. What is task T in this particular problem statement? Task T in this particular statement is labeling a particular mail as spam or not spam. This is the task which must carried out by system or a computer program. What is an experience E in this case? An experience E is nothing but previously programmed or previous data which is having patterns of non-spam mails and also having the patterns of spam mail. Using that experience, new task will be classified as either spam mail or non-spam mail. What is performance measure? Performance measure is nothing but in machine learning we call it as accuracy or the percentage with which a computer program have ability to label a mail as spam or not spam. Say for example, I say with 94% of accuracy, a computer program is able to classify a mail as spam or not spam. With the passing of time, this accuracy also improves. That means now accuracy is, say for example, 99%. So we say machine is learning how to classify a mail as spam or not spam. So basically machine is considered to learn only if it is able to gather the experience by doing a certain task which improves its performance in doing the same task in future. Now what is the machine learning process? So basically we say do really machine learn? Machine actually learns in 3 steps. First step is input data. Second step is abstraction and third step is generalization. Input data is nothing but past information or past raw data which is utilized as a basis of future decision making. Second step is abstraction. With the word abstraction, we actually mean that input data is now represented in a broader way so that it can be represented by an algorithm. Third step of machine learning is generalization. With the process of generalization, whatever the abstracted representation is now generalized or which is used as a framework for future decision making. Let us understand this machine learning process with the help of one human learning example. Consider a student is preparing for an examination with a traditional classroom and book learning method. One good way to prepare for examination is trying to learn by heart or trying to memorize as many things as possible. So this particular strategy will work very well when the syllabus of an examination is not very vast. It is very less. Say for example 2 to 3 chapters. And the type of question that are going to asked in an examination are very simple and straightforward. Directly lines which are read from the book can be written as an answer to the questions in an examination. So in these kind of situation, memorization or learn by heart method will work very efficiently. But what will happen? The syllabus of examination is very vast. Say for example, there are 50 to 80 chapters in an examination or book contains more than 1000 pages. Also, the learn by heart thing or try to memorize a particular thing is limited by one's capability of memorizing. And also, what will happen when you memorize a book but the questions that are asked in exam are not straightforward? That means you cannot directly copy or write down the same answer which was actually presented inside the book. So the complex questions are there in exam. Learn by heart or memorization would not work. We need to find out the knowledge which is presented inside the book. So not only raw information is only consumed, but understanding of that information is more important to us. So we will try to figure out what are the key points given in this particular book. Or we will outline the important topics that are asked or what are the information that is given inside that topic. That is nothing but simply a conceptual mapping of course content with a knowledge pool. So what we will basically do, we will try to find out all the knowledge which are related with some topic and we will make some key points or outline points. And that will help us to find out the answer in an examination of complex type questions. Say for example, one book is given in which there are listing of all the animals and their living characteristics. So to by heart, the characteristics of each and every living animal is very difficult to us. But it would be easier if we try to categorize these animals according to their characteristics. Say for example, animals are classified according to their characteristics such as vertebrate and non-vertebrate. That means those animals which are having skeleton and which are not having skeleton. Again, vertebrate animals can be later on classified as such as mammal, fish, amphibians and reptile. So in this way, we can obviously try to categorize these animals and try to fit it under some particular category. So what will happen during the examination or whenever the characteristic of particular animal is asked? We will try to figure out where the basically that bird or that animal sits inside the characteristic category. Say for example, whether a particular animal is inside invertebrate or vertebrate. If it is having skeleton, whether it is fish, whether it is an amphibian or whether it is a reptile. So we can easily able to recapture the characteristic or recapture or identify the characteristic given the category of that animal. So basically we have vast pool of knowledge which is available as a form of data input. In spite of using that complete raw data, try to conceptually map this data into some knowledge pool. That is nothing but the process of abstraction. and making these critical decisions of future based on this extracted knowledge is called as generalization. So we will try to find the conclusion of abstracted knowledge in a form of generalization. We will try to make some simple rules which can be later used on to make some future decision. Let us understand the process of abstraction in detail. The knowledge which is fed as a form of input to the data cannot be used in its original form. Obviously, it must get abstracted. This abstracted knowledge in machine learning is called as a model. A model is nothing but a conceptual map which is derived from an input data and which summarizes the knowledge from raw data. We can represent a model in any of these ways. Say for example, I can represent a model in a form of computational block. We can write down series of if-else statements to represent a particular model. Or we can write one mathematical expression or two to represent a model. So second way of model representation is nothing but mathematical equation. Another option for writing or to pre-present a model is a specific data structure like tree or graph. We can prepare a graph or a tree which can represent to a machine learning model. Or we can simply group out the similar observation into a logical group, which can also represent a machine learning model. So while we are actually saying that we have performing an abstraction step, we are actually preparing a model. And that model can be in any of these forms. A model can be a computational block, or it can be a mathematical equation, or it can be a structure like tree or graph, or it can be simply logical grouping of observation. Now, the question arises, what type of model we always try to or we must create to make a machine learn? So the choice of model or type of model we must select to perform a machine learning task is a human related task. That means a person should take a decision, the type of representation in which we can represent an abstracted model. So there are a lot of parameters which can decide what type of model a machine learning can adopt. First parameter is type of problem that must get solved. Say for example, we want machine to predict some value or to find some trends, or whether machine learning wants to predict or forecast some value or to find out the different grouping of data. According to the type of problem to be solved, I can choose either of type of model to represent a machine learning model. Second parameter to choose any machine learning model is nature of input data. We must finally first figure out what are the different inputs to the algorithm or what are the inputs to the machine learning program. Whether this input is consisting of exhaustive data which are having numerous numerical values which and some of them are missing, or the input is an image in some particular format, or whether an input is a video or a document. So depending upon the nature of input data, we can choose an either type of representation of model. Third important characteristic to make a model selection is domain of problem. Machine learning application is going to solve a business critical problem. For example, identifying the target customer segment or to recommend a new product to a particular customer or finding the best matching deal of a particular customer, or whether our application is healthcare industry oriented, such as identifying a tumor is malignant or benign. That means tumor is giving a health a risk or just innocent tumor. According to that, we can choose either of type of model representation in an abstraction stage. Next is generalization stage. While model is selected and represented with the help of input data, we try to simplify this model or try to generalize these model so that new model will be able to take decision of future. The model is trained according to the input data called as training data. Or new incoming data have some characteristic which is not possessed by our trained data. So while generalizing a model, we try to make our machine such generalized that even though some information which is not captured by the training data might get captured in future in an accordance with unknown or test incoming data. Here, a precise decision making approach might not work. There are some decision in which risk has to be taken. So this generalization is an approximation of our model. Approximation will try to identify or to try to figure out new trends which are not previously captured by our training data and which might get captured or which might get identified in our future data. Say for example, now I have one problem and that problem is needed to be solved using machine learning. What is the framework using which I can solve this particular problem? Let us see that. A new problem which needs to be solved using machine learning, we have to follow a simple framework. First, we will find out what is the problem. Obviously, we have informal description of problems. Say, for example, I want to solve or I want to predict a new word from a given typed sentence. So I have a Word document and whenever the user types a particular word, whatever the second word, what second word should be will be predicted by the computer system. And that type of machine learning problem I want to solve. That is called as an informal description. We also need a formal description. That means we have to identify what is a task, what is an experience, and what is a performance. So trying to predict a next word from a typed word is an informal description, and task in this particular problem is predicting a next word from a previous word. What is an experience in this case? We have a complete guide or a skeleton of words. That means we already have a skeleton of word in which we have what is the previous word and what can be possibly the next words in a particular different scenario. What is performance measure P in this case? The previously matched words. That means how many times machine predicted a word and how many times user chooses it predicted word as a correct word. That is nothing but an accuracy of previously done task. We also need to identify similar type of problems which have solved using machine learning in past. So that will help us as a baseline or as a bedrock of our new solving problem. Second, after identifying what the problem is, we will try to find out why we need to solve this particular problem. What are the different motivation behind solving the problem? Is this a problem which must get solved by machine learning or not? What will be the solution benefit? Is it going to benefit a particular customer or what are the target audience of this particular project? And we have to obviously find out this solution uses. What are the different application of this particular machine learning problem? At the end, we will try to figure out how to solve a machine learning problem. We will try to find out data collection method. What will be the data source? What will be the size of input data? What type of data input will be there? All these characteristics will be identified. Then we will try to prepare data. The data conversion, which is an object which is collected in a raw form and then later on translated into machine acceptable form. That is nothing but data preparation stage. Later on, we have to decide what type of model will be there. Whether it will be a predictive model, whether it will be a descriptive model. A model can be represented by computational block or it can be represented by a mathematical equation and so on. These kind of decision will be taken. And at the end, we will set evaluation parameters. That means after implementing a problem which is solved by machine learning, what are the performance measures or parameters which will justify the performance of a machine learning program. So that is all for today. In today's video, we have tried to cover introduction to machine learning, what is human learning and types of human learning, and description of machine learning definition as well as the process of machine learning. Thank you everyone for watching this video. This is Munira Topia signing off.